can get started for today. Yeah, so it's all recorded. So welcome back. I guess right now it's just Derek. You get a private lesson today to Python level 4. And we're just gonna pick up where we left off with strings. And so, let's see, we have Amy now. Let me start sharing my screen. I have these slides. I was wondering, I don't know if Derek or Amy, did either of you do the homework for last week and would like to share the solution?
I did it.
Okay, I guess actually I'm gonna stop my screen share. Do you want to take control of the screen and show us how you did it?
So this is what I did. So I made a sentence and then I did all the things that you told me to do, like the B, change all the B's to 6, the A's to at, and then I did the print word -1, and I then got this.
Awesome. Yeah, so that's exactly what I was looking for. I think there was one more thing. Do you remember how to find the length of a string? How we did that in Python?
Was it like word index or something like that?
Close. So word.index is a function that we talked about, and that took like a character or a string and told you where it is in the original one. To find the length of a string, we had a function called len, L-E-N. And I have another slide to review that later. So that's all good. But yeah, that was a good solution. And I think the submissions I saw, it pretty much looked like that. The one thing that was a little bit tricky that I didn't, was hoping people would figure out, and they did, was that the replace method, you have to reassign the result of the replace back into either the original variable or a new variable every time you did the replace. Because we're going to talk about this later, when you call the replace function, you're not actually modifying the original string. So when you do like replace B's with 6s, it doesn't actually replace. All it does is create a new string that has those things switched around. So now you have two different strings. And if you don't store the result of the replacement, it's just going to get lost, right? If you don't hold on to it, Python's not going to hold on to it for you. And so I saw, Derek, in your solution, you were like, word equals original string, word equals word dot replace, whatever, word dot equals word dot replace, whatever. And so each time you're kind of storing the result back into Word, and it's like building up, layering the replaces on top of each other, which is exactly right. See, Mason, glad you could join us. We're just going over we looked over the homework. I'll post an example solution to Classroom. And I have kind of one review question that was not part of the homework, like a little bit extra. So really short question. I have this kind of 2 lines of Python code. I was wondering if someone could describe to me either what it prints out or kind of what it's doing, right? What does this mean in Python? Okay, I see Derek, are you raising your hand?
So I think it will print out the space at the end.
Could you repeat that again? I'm sorry.
I think it will print out speed and then with a space at the end.
Okay, yeah. So can you tell us how you got that answer?
Because if there's nothing at the beginning or the end, it just goes from like the beginning. So so 0 is S, 1 is P, 3 is E, 4 is 0 is S, 1 is P, 2 is the other E, 3 is that other E, 4 is D, and then 5 is the space.
Awesome. Yep. So I'm glad that you remember like spaces do count as letters. That's really important. Another thing is you did remember that this is what's called slicing. So we kind of have a starting index and we have an end index typically, and we're getting a slice based on the start and the end. And I'm glad you reminded the class. If I don't say a start specifically, it just chooses the beginning of the string to be the start. If I don't say that string stops. Okay.
Oh, that's an accent, yeah.
And then the only thing that is a little bit tricky is what happens at this end index. And so actually, the correct answer to this problem is it will just print out speed. It won't actually print out the space at the end. And that's because it goes up to, but not including the end. Right, so we say index 5 is the end, and you're correct that that corresponds to the space. That is index 5. But when we're taking a slice, we don't include the end point. We do include the start. So whatever the starting index is, we do include that character, but we don't include the ending one. So it's a little bit different for the start and the end. But otherwise, that's exactly right. And I think I have it on a Colab notebook. So here, just to show it working, you can see once it starts up, it prints out speed, and I can even do like, I'll just do a square bracket :5 plus a period. So the string period. So this like shows you where the end of the string is because you can't really tell if there's a space or not yet. If I put the period, you can see that the period shows up right after the D. So there is no space. Otherwise, oh, I see in chat, Evan's here too. No problem for being late. We just went over homework and also just this short review question. A sample homework solution will be posted after class today if you want to take a look. But overall, submissions I saw pretty good. So opening up the slides. Today, I just want to go over a few more things about strings. We're going to learn a couple more functions that exist, things that you can do with strings. And then we're going to move on to a new topic. So it's not all just going to be strings today. So the first one, and this is actually a little bit of review from last week, is this built-in len function that I talked about when we went over the homework. So the reason I'm showing it again is that the len function's probably one of the most useful ones that you're going to learn. It's very useful because it doesn't only apply to strings, but you can also find the length of some other things that we're going to talk about later on in this course. But for strings, the length of a string corresponds to how many letters there are or how many characters there are. Right? And really quickly, I want to ask a question. If a string has a length of 3, what is the last index? What is the index of the last letter of that string? Feel free to unmute or just put it into chat. And if you didn't hear the question, it was, if you have a string and it has a length of 3, what is the index of the last letter in that string? So I'm looking for a number. Doug says 2. Amy says 2. So I agree 2 is the correct answer. Amy, could you explain it to people who don't know or sure? Mason also says 2. That's great. Why is it 2? And maybe why is it not 3? Okay, so if the length is 3, why is the last index not 3 as well? Why is it something different? Yep, you're exactly right. So the thing that you have to remember about indexing is that it starts at 0. And so when we're doing the length, we're kind of starting at 1, right? A single character has length 1. However, a single character, if a string that only has 1 character, that character has index 0, the first index. And so if you have a string with 3 letters, your indexes are going to go 0, 1, 2. Right? And so the last index is always 1 less than the length. And this maybe can connect to why we do string slices the way we do. Kind of like the end of a string, the length of it, and also like the last index, they're kind of one off. You go up to, but not including the length. And so that's why slices are kind of how they are. You go up to, but not including the last index, because you kind of have this discrepancy. Shows on the slide a couple other functions. Honestly, I haven't found them super useful in my experience, but they exist if you want them. So you can find the max and the minimum of a string. And what it does is just finds the max and min alphabetical order, the character that has the highest or lowest alphabetical order in the string. And so I can show an example of it. So I'll leave the comment max and min functions. So let's make a string like hello world. And if I take the max of x, you can see it's W. So does anyone want to guess what the min of x is going to be? So if the max is W, what do you think the min is going to be? Oh, Derek, I see you have your hand raised and you put it into chat. So E. So I agree, it's going to be the first letter alphabetical wise. So the first letter here is going to be E. Or I don't think it fan. I'm not sure what's going on here. Sorry about that. It's definitely being a little bit weird. Oh, my bad. So actually, it's a little bit tricky. I shouldn't have done this string. So what's happening is it's printing out a space. And so let me pull up something really quick. It's called an ASCII table, or if you look up a Unicode table. So an ASCII table is kind of an encoding between numbers and letters. And so when you find the max and min, it's based on these ASCII values. And so here you can see, like, for example, the letter M has the number 109 associated with it. The letter G has the number 103 associated with it. And so when you're finding the min of a string, it's just finding the character with the lowest ASCII value. And so actually, if we look at spaces, it's over here. The space character has number 32, and that's less than any of the letters, right? So when we print out the min of x, it's actually going to print out the space. So to fix this, I'm going to remove the space, and now, okay, it's D. I don't have my alphabet in order. That's because D is the first letter in the alphabet that shows up in this string. You'll notice in the ASCII table, capital letters are considered lower or smaller than lowercase letters, which is a little bit weird. So for example, if I change this to capital H, hello world, you will see that the min x is now H, capital H. And it's just because of these ASCII values. That's how the ordering is determined. We have this count function. If you want to count how many times a letter or a substring appears in another string. So you can have a word and you can count the number of L's in it. And you can also count more than just a single letter. You can count like a whole substring. You can count how many times like AB shows up in your string. this is a little bit optional, but what's happening here is you put kind of the range of the string that you want to search through. So this is an optional thing that you can do with count. Instead of searching through the entire string and counting how many times it shows up in the entire string, you can count how many times it shows up in just a section of it. And what you do is you give it a starting index and an end index. And as you might guess, this end index is going to be not inclusive. So if you're counting i's and there happens to be an I at index 8, you're not going to count that because it's not included in the section. So does anyone want to make a guess at what this is going to give? Something you can assume. So I said for a count, you can give a starting index and an end index. If you only give one number, it's going to consider that to be the starting index. So Derek says C7. Anyone else want to give an answer to this? There's, I think, just one tricky bit of this problem. So I'm going to copy this over into my Colab. Which is over here. So I'm going to leave a comment here as well with count. And if I run this, we see that the answer is actually 6. So I agree. I would say the answer is either 6 or 7. And so let's talk about why it's 6. Right? Why is the count of is in string 1 6? So this 4, what is this 4 telling us? Does anyone know or have a guess? Okay, Derek, I see you have your hand raised.
Maybe it starts from the 4th letter in the string.
In 4th index is the correct. So here, what we're saying is we have string 1, and we want to count the number of times this substring, which happens to be is, appears, but we only want to start counting from index 4. And so let's look at what index 4 is in our string. So M is index 0, Y is index 1, the space is index 2, I is index 3, and S is index 4. And so what it's saying is I want to start looking from index 4. And so really what it's doing is it doesn't care about anything that happens before index 4. And so it just like cuts it off. Right? And so it's only looking at the part that I've highlighted. Right? And so if we're only looking at the part of the string that I've highlighted, we count the number of times is shows up. We have is here, is here, is here. There's 3 times. We have 3 more is's here, so that's 6. And notice, yes, there is an is here, but since we're only looking from index 4, we don't include the I. So there's no is here, like we don't count this one because we're kind of starting in the middle of it. If this happened to be 3, however, if we started looking from index 3 and I ran it again, now you'll see it's 7, right? Because now I'm starting the search a little bit before, and so then I can capture this one as well. But since I'm starting at index 4, it's right in the middle of this one. And so since it's like kind of cut in half, we don't count it because we don't count halves. We only count complete matches of is. Did that explanation help a little bit? Let's see nods. Yeah, so I think the good thing about Python and these functions is you can kind of make a guess at what these things are doing. So maybe this for is a little bit confusing, but you can see the function is count. You have a string, you have a substring. So you can make a guess, hey, this function counts this inside of that thing, right? We have the index function. You can say, oh, it gives you an index. We have the len function. Oh, it gives you the length. We have the replace function. Oh, it replaces things. Here's some more kind of self-explanatory functions. We have the upper function and we have the lower function. So notice these are a little bit different because these don't take in any inputs, right? We just say word.upper parentheses and nothing inside the parentheses. And that's just because to convert a string to uppercase or to lowercase, you don't really need to tell it anything more than that. Right? You only have to tell it, hey, I want it in uppercase, and that's it. You don't have to give it a starting index, an end index, or a substring or anything else. So you don't need any inputs to the function. One thing I want to make clear is that this word thing, this is just any variable that's a string, right? So it says word here just because in the previous slide or the slide before, yeah, right here, we assigned the string hello to the variable word. So when we do any string dot upper turns that string into all uppercase letters. So for example, if I say like this variable name speech is equal to I like Python, I can say yell is equal to speech.upper, right? And I could, if I print out yell, you can see now it's all uppercase. It's like I'm yelling. I can also do lower. I don't know, y equals speech.lower. And if I print out quiet, you can see that it converted the capital I in the original one to a lowercase I. So pretty self-explanatory. Sometimes it's useful. So can anyone think of when this would be useful? Maybe like a hint at what I'm going towards is like, think about you're trying to process some sort of input and you're looking for some sort of string inside of your larger one, right? So for example, you scraped some sort of article from the internet and you want to find how many times the word apple shows up in your article. Why might these upper and lower functions be useful? Anyone want to make a guess or think they know? Maybe another hint is you're looking for the word apple in your article. Sometimes apple might show up with a lowercase a. Sometimes it might show up with a capital A because you're talking about the company, or maybe it just shows up at the beginning of the sentence. So it has a capital A, right? And so you really don't care about the capitalization. You just want the number of times apple shows up. And so why would it be useful to have one of these functions? Oh, Derek, I see you raised your hand.
Maybe you could search for app, like you can convert all the A's to lowercase and then search it, or all of them, then convert it all to uppercase and then search.
Yeah, so I like what you're thinking about. And that's very similar to kind of a technique a lot of people use when they're dealing with text. And so one way to do it, I think the most common that I see is you take some sort of input, wherever you got it from, and you just convert it to lowercase. So you convert the entire input to lowercase. And then you search that converted string for whatever you're looking for. And so now you don't have to worry about if someone capitalized the first letter or if someone capitalized a letter in the middle. You're going to count all of them, right? And so that's useful if you don't care about the capitalization at all. Of course, if you do care about the capitalization, you don't want to just convert everything to lowercase because then you lose information. But if you don't care about casing at all, it's often very useful to convert a string to lowercase or convert a string to uppercase. So you know for sure everything's uppercase or everything's lowercase. Instead, if you didn't do that, you'd have to do like my string dot count apple with a capital A plus my string count apple with a lowercase a plus my string dot count apple with a weird capitalization, right? To get every single instance of apple that shows up. But if you just convert everything to lowercase, you only have to search for one thing. You only have to search for lowercase apple because that's the only thing that exists. Everything's lowercase. Here, this goes into something we're going to talk about later, Booleans, true, false values. But I think starts with, ends with is not super useful, but they do what you think they do. You have a string variable, you say dot starts with, and you give it some sort of letter or some sort of substring. And it just tells you yes or no, does my string start with that combination of letters? Equivalently, you have the ends with function that takes in letters or a string and tells you, hey, does your string end with that combination of letters in that exact order? So in my experience, I haven't had to use it very much, but they exist if you want to use it. What is another very useful function is this word or the strip function. And what it does is it just removes any white space at the beginning or end. It doesn't remove white space in the middle. It doesn't do that, but it just chops off white space on either end. And why this is useful is because, again, when you're dealing with input from a person or from like the internet or just somewhere where you aren't sure what it's going to be like, the input can be messy, right? It can have weird capitalization, it can have weird spacing. And so oftentimes you want to convert everything to one casing, whether lowercase or uppercase. You want to strip the input so that you don't have to worry about random white spaces showing up in your code. And so strip, I think I've used it a lot. It is a pretty useful function. Replace, we did this in the homework. Replaces an old thing with a new thing. Pretty self-explanatory. And split, I'm not going to talk about today. So the last thing before I have a couple like quiz questions about strings and then moving on to a new topic for today. The last thing I want to talk about before that is this idea that strings are immutable. And we kind of touched on this when we went over the homework, but let's break this idea down. So does anyone, I guess I already have it on the slide, but immutable is a term that we have in computer programming, not just in Python, but in other languages. If you're studying like Java, C++, anything like that, they also have this idea of immutability. So when something is immutable, it means it can't be changed after it's created. And so if you actually break down the word immutable, mutable, well, mute stands for, is like change, right? Like mutation is a change in something. So it's able to be changed. Mutable means able to be changed. And then im says not, right? So not able to be changed. That's literally what it means. And so strings are immutable, which means that once you create a string, you can't change what it is, right? You can make new strings. You can make different strings. But once you make one, you can't change it afterwards. And so if we look at this example, what this example is trying to do is it creates a string var, then it says, hey, I want to change the letter at index 2 to P instead of being an E. And so if you try to do this, and I can show it off on my screen, you're going to get an error. And so you're going to get an error, and the error message just says the string object does not support item assignment. Essentially, what it's saying is strings can't be assigned to new things like this. What you're trying to do is modify a string that already exists. But hey, strings are immutable. You're not allowed to do that. And so this principle kind of explains why functions like replace don't actually replace the letters. It can't. It's not allowed to. Instead, it returns a new string with changes in it. Same thing with the functions that we talked about today as well, like upper and lower. If we go here, and we can see that speech.upper gives us the uppercase string. Speech.lower gives us the lowercase string. But if we just print out speech again at the end, you can see that this variable speech is still the original string that I set it to. It hasn't changed. That's because it can't change. Right? When I do speech.upper, it does not turn the letters in the original string to uppercase. It doesn't touch the original string. All it does is make a new string that is what it's supposed to be. And it's kind of an important difference. One thing that you'll see is it can be very inefficient when you're adding strings together, because when you add strings together, you can think, oh, you're just like taking one and putting another one at the end of it. It's yes, but since strings are immutable, you can't just like stitch them together like that. When you're adding strings together, what's actually happening is you're making a new string that's the length of the two strings that you're adding combined. And then you're like kind of copying things over. And so if you have a string and you're adding a letter, adding a letter, adding a letter, adding a letter, what's actually happening is every single time you're adding a letter, you're making a new string, you're copying everything over, and then you're adding the new stuff. And then when you add another letter, you have to copy everything over, put it in the right spot, right? Because it can't touch the original one. It can't modify strings that already exist. All it can do is make new ones. And so this is what I just showed you on Colab as well. Like, for example, the upper function, it doesn't touch the original, right? It makes a new string. And if you don't store the new string anywhere, it's gone after that line of code. The original one is untouched. And a lot of times this is good behavior. You don't want someone else to accidentally mess up your variables by calling these functions what they should have, right? So it's kind of safe in a way that you can call these functions, but your original thing is still the original thing. So now I have a couple multiple choice quiz questions. I'm just testing some of the important concepts of strings. So this first one is just basic string slicing. It's similar to the review that we did at the beginning, although I think in a way it's a little bit easier because we say the start and the end correctly. So I want to take maybe 30 seconds. I want everyone to type in something in chat, A, B, C, or D. I want to see what everyone thinks this should be. So I have one response for C, but I want multiple responses. So Evan says O or maybe D. Yep, so the letter D. So I have one answer for C, one answer for D. Anyone else want to agree with one of those two or choose a different answer? Mason says C. So 2C, 1D. How about Amy? What do you think? Okay, Amy says C. Is that everyone? Yeah, I think that's 4. Yeah. So if I take this code and I put it into Colab, So I copied everything over. And the moment of truth, let me run this. What is the correct answer? There it is. So it's the letter G. So let's answer A. So unfortunately, no one got it correct. But does anyone want to take a stab at explaining why it's G now? So I see some messages in the chat. Mason said what? Evan mentioned the Stack Overflow link. Yes, that is correct. Everyone uses Stack Overflow when they get stuck. But for this question, why is the answer G or the letter A, choice A? Does anyone want to explain? Yeah. Go back here, look at the code. So I guess taking this step by step, can anyone tell me what the term for this kind of operation is called? Where we have a number colon another number, starts with an S. What is this thing called? Not a string, something to do with strings. Like what do I call this? What are we doing to this, the variable here? Where so we're slicing the string. So we're kind of like cutting it up, extracting a piece out of it, right? So this is what we're doing. When you see the square brackets with a number colon another number, we're slicing of the string. And so can someone tell me what these zeros and ones mean? So what does it mean to slice from 0 colon 1?
Go from 0 to 1.
Yes, so those are our starting and ending indices for our slice, right? We're chopping the string up, but we have to know where are we chopping, right? So here we're chopping at 0 and we're chopping at 1. Now the question is, what happens at exactly that boundary, right? We know we're interested from 0 to 1, but is it inclusive or is it exclusive? And so looking at this example, can someone tell me, are we including the string, the letter at index 0 in our output?
Yes.
Yes. So this means the starting index is inclusive. It includes the letter at the starting index. But if we look at the end index, index 1, are we including the letter at index 1?
No.
No, right? We're only printing out one letter, G. So we're not including the end index, right? So what's going on here is it's slicing our string from index 0 up to, but not including index 1. And so if we look at our string, we start at index 0 and we go up to, but not including index 1. And so that just gives us the capital G. So if I switch this up a little bit and say 3, 6, can someone tell me now that we've went over this again, what is this new slice going to be? I want to see at least a couple answers in chat for this one. So Amy says Jube, J-U-B. I want at least one other response. So you can agree or disagree. So Mason says he agrees. And so it's great. We have some consensus. If I run it, you can see it is indeed Jube. And so going with what we just learned, we start at index 3. So in our string, it's 0, 1, 2, 3. That's the capital J. And then we go up to, but not including index 6. So 3, 4, 5, 6 is the I. So we go up to the I, but we don't include it. So it's just JUB. So that's string slicing. So this is something that we mentioned once last week, but haven't really covered it too far. What is this gonna be? So this is negative indexing. What does a negative index mean? Is it allowed? Is it an error? Or is it completely fine? If it's fine, what is it gonna be? So I want everyone to put an answer in chat, A, B, C, or D. If you're not sure, it's completely fine to make a guess. I just want to see what everyone thinks about this question. I will say, if you do have Colab open, try not to just put it in Colab before I go over the answer. I want you to make a guess before you actually run the code. So I guess as a hint, we know the first letter has index 1. And we know the letter to the right of it, the first letter has index 0. And so the letter to the right of it is Y. And that's index 1, one more. So what do you think index -1 is going to be? So my hint is it's not an error. It is something that's allowed. And so we have a little bit of some consensus for choice A, which is the letter C. And so I agree with this actually. So I think the best way to think about negative indexing is that -1 is the last letter, right? So -1 is the last letter. That means if we just count backwards, -2 is the K, -3 is the C. Right, so that's choice letter A. And I can show you guys that I'm not just making this up, that this actually is something valid in Python. I will put it into my Colab as well. And if we run this, you can see it prints out the letter C, which is choice A. So let me see, Derek, Amy, Mason, good job on choosing it. So this last multiple choice question, it's a little bit of it's a little bit tricky. It's a little bit interesting. Again, I have this expression print S1 times S dot index N. So you can either say this doesn't work, it's not valid Python code, or it's the string 55555, the string N, or the string YYYYY. The way I would recommend approaching this problem is breaking things down one by one. What is S1? What is S dot index N? What is that times that? And then you have the answer. So I'll wait maybe a little bit to get some answers in chat. So Derek said D. I want at least 3 responses to this question in chat. Mason says A, so we have a little bit of a disagreement. So let's get one more answer. Hopefully the third answer agrees with one of the first 2. If not, that's completely fine as well. We'll just go over the answer afterwards. So let's get one more answer. Amy or Evan, do you want to try this problem? Again, if you want, you can just make a guess. Make your best guess. We'll go over it either way. I'm going to put it to Colon, just get ready. But again, Amy or Evan, do you want to choose an answer? I agree that A and D are probably the top two choices for me if I was looking at this problem. But unfortunately, it has to be one of the two. How about we break this down? So if we break this down a little bit, I'm not going to run this how it is. So I'm not going to run the answer yet, but I want to break it down piece by piece. So let me comment this out. So print S1. So can someone tell me what this is going to be? What is S square bracket 1?
Why?
Why? And why is it y? How did you get that?
Because the first one is P. So P is 0, so Y is 1.
Yeah. So when you have a string and square brackets with a number, that is indexing into the string. You give it a number, it gives you a letter. Right? This is like a more simple thing than we saw before. This is a slice where you have two indices. Here's just a single index. You get a single letter out of it. Okay, so that's exactly right. You get 1. Now, the slightly trickier one, but not too tricky. What is S dot index n? Let's Amy or Evan. Okay, that's good. So it's 5, and it's because this index function is kind of the opposite of this square bracket thing. So instead of giving a number and getting a letter, you're giving a letter and getting a number. So here we're giving the letter n, and we're getting the index that corresponds to it. And so if we look at our string, it's 0, 1, 2, 3, 4, 5. That's the index. So S dot index n is 5. So if we break down our original question, what is this going to be? We figured out that essentially what the answer is going to be is the letter y times the number 5. And so this was why I think A or D is probably the top two choices. Either you say, hey, you have a letter, you have a number, I don't know how to multiply them together. That'd be the correct answer in like Java. You can't do that in Java. You can't do that in like C++ because they're different types. However, in Python, this is allowed. So this is not an error. And the answer is choice D. What this does is it takes the letter Y and just repeats it 5 times. So if we run this, it's not an error. It actually does output something. Awesome. So that's the multiple choice questions I had. Let me just check on time. Okay, we have about 10 minutes left. That's perfect. I'm going to introduce the new thing for this week, like a brand new topic. It's a pretty small one, so we're not going to finish it today, but we're going to cover a good chunk of it today. And that's just a new data type. So just like strings is a data type, the next one we're going to look at is the Boolean data type. You might have heard of this before. I definitely mentioned it a couple times, but we're going to formally discuss it now. So the Boolean data type is the data type for true false values. So very simple, Booleans have only two values, true and false. Unlike integers that have basically an infinite amount of values, not really infinite, but almost infinite. And also strings, it's not really infinite because computers have limitations, but you can make a string whatever you want. A Boolean, however, you don't have that flexibility. It's either true or it's false. Nothing in between, nothing else other than true. And so a sneak peek is we have a couple more operators to talk about now, because there's things called Boolean operators. So remember back in the second class of Python, we talked about the arithmetic operators, assignment operators, the relational operators. Here we have Boolean operators. Right? So it's just a symbol that operates on Boolean values. And so what kind of things exist? We have or, and not. So those are the ones I'm gonna cover today. So I think not is the simplest one, of course. So not is a little bit different than and or. And or, those operators, take two different Boolean values. So x and y, x or y. So you have two values with the operator, just like how plus is an operator with two values. Not, on the other hand, is just a single, it operates on a single value, right? So not x just takes x and flips it. So if x is true, it becomes false. If x was false, it becomes true. It just is the opposite. So not turns whatever it's affecting into the opposite of it. Right. We have now the operators x or y and the operator x and y. So the question is asking, tell me the result if x is true and y is false. So what is this going to evaluate to if x is true and y is false? Does anyone want to guess? A hint, the answer is going to be either true or false. For the next section, pretty much any answer to a question I asked you is going to be true or false. So is this true or is this false? You can think of it almost like in the real world. Right? If someone says, I want orange juice or apple juice, and you give them apple juice, are they happy or are they not? Like, does that satisfy or no? So for or, the answer to this is actually true. So the reason why this is true is or is kind of, I like to think of it as less strict, right? It's pretty lenient, it's pretty relaxed. And so x or y says if x is true or if y is true, I'm good. So this column is kind of one way to think of it. I think it's a little bit complicated, but if we just look at this operation x or y, we're saying if either the left side or the right side is true, then the whole thing is true, right? One or the other. So the only case when this is not true is when both of them are false, right? Because if x is true, then the whole thing's true. If y is true, the whole thing is true. If both of them are true, well, that's extra true, right? Which is still true. The only case where this is not true is when both sides are false, right? Because false or false, you don't have any truths. The left side is not true, the right side is not true. So you can't be true overall. Right? So this is why I say it's a little bit lenient. there's only one case when it's not true, right? Like you can 3 out of the 4 cases, it's going to be true. Only one of them is this going to be false, right? And on the other hand, is a little bit more strict. It requires both sides to be true for the overall expression to be true, right? And so this is strict because you need X and Y to be true, right? And that's why it says and why this one is or. Right? So X or Y, you cannot have a choice, one or the other. And you don't have a choice, you have to have both. So or means one of the two or both. And means you have to have both. Yep, so the answer to this one, if X is true and Y is false, then this thing is gonna be false. And so make that a little bit clear what's going on here. So I'm saying if X is true and Y equals false. So I create these variables and I want to print X and Y. So this is false. And if I print X or Y, this one is true. So if I change this, for example, if I change this one to true, then X or Y, this is still going to be true, right? Because one of them is true. X is true, so the whole thing's true. X and Y, on the other hand, this is going to change. Before it was false, but now both sides are true, so the whole thing is true. Right? So in this case, everything is true. And from here, you can create with something what's called a truth table. You can find all combinations of X and Y. So true, 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 false, false, true, false, false. There's all the different possible combinations for those values, and you can determine whether the expression is true or false. And that's what's called a truth table. It basically is like a answer key to any of these questions. Given these inputs, what's the output? And we're definitely going to do more practice on this later on. So if it's a little bit confusing now, don't worry, we're going to do more next week. Before I let you go, I just want to talk about places where you've probably seen Boolean values show up before. And some of these I've actually talked about. So if you look at all the relational operators, the result of comparing values to each other is a Boolean, right? When you compare the variable X with the number 5, you get an answer that's true or false, right? So let me do this here. So actually, let's say num equals 7. And I want to print num greater than 6. And so this is a comparison. We're comparing num with 6. And so in this case, num is 7. And so this is obviously true. 7 is greater than 6. Yes, true. If I change this to 9, however, this is going to become false. Okay? Because 7 is not greater than 9. It's false. And so all of these relational operators, greater than, less than, greater than or equal to, less than or equal to, equals, not equals, these comparison operators, relational operators, they give Boolean results. The last ones is and is not. They are a little bit similar. They're kind of like equals and not equals, but they have slightly different applications. And honestly, we haven't really seen where those are useful, so I'm not going to focus on them right now. But that's all the time I have for today. Hopefully the string stuff felt a little bit comfortable. I know the Boolean stuff might be still a little bit shaky. We're definitely going to focus on that next week. Homework this weekend or this week. I don't have a slide on it right now, but I will post it to Google Classroom like usual. I will also post this notebook with the examples as well as solutions to last week's homework to Classroom as well. So look out for that. But that's all the time for today. I know we've reached 4 o'clock. If anyone has any questions, I'd be happy to answer them now. Otherwise, have a great week, have a great Columbus Day, and I'll see you next weekend.